Okay, let's get into it. We're talking about a really monumental time in history. Just a massive shift in how people thought that, basically built the modern world.
We're talking about the scientific revolution. It all gets started in Europe around the 16th century.
And it really was a revolution. I mean, it's a battle of ideas.
It was. Because before this, the world was pretty much governed by authority. If you had a question, you didn't run an experiment. You looked it up.
Right, in old Greek texts from
Yep.
people like Aristotle.
Exactly, or from religious texts. And the number one belief was that the Earth was the fixed, unmoving center of the entire universe, the geocentric model.
So today we want to look at how that changed. How thinkers stopped just, reading old books and started doing something totally different.
They started using observation, logic, and experiments.
To test things in the real world.
Mm-hmm.
So you're going to pinpoint the people and the moments that replace that old authority with actual, tangible evidence.
And there's really no better place to start than by looking up at the sky. Because that's where the whole old system, the idea that humans were at the very center of creation, first started to crack.
Let's start with Nicolaus Copernicus. He was a Polish astronomer, a mathematician, and he was really bothered by the math of the universe. If the Earth was the center, the movements of the planets were just impossibly complicated to calculate. They had to invent all these weird loops and epicycles to make it work.
And he didn't even have a telescope. He just used math.
Yeah.
Pure calculation to argue that the sun, not the Earth, had to be the center.
The heliocentric model.
Yep.
Yeah.
Sun-centered. And you have to understand, this wasn't just a small tweak. This was a cosmological shock.
It seems so obvious to us now, but you can see why it was so controversial. I mean, it goes against what you see every day. The sun looks like it's moving around us.
And it demoted us. Earth wasn't the special central point anymore. We were just another planet going around a star. It was a huge psychological leap, and it took a long time for people to really accept it.
So what did it take? What finally pushed the idea forward?
Well, it took real physical proof.
Yeah.
And that came from Galileo Galilei, an Italian scientist.
Galileo.
He was maybe the most, let's say, aggressive supporter of this new evidence-based science. He built his own telescopes, way more powerful than anything before, and he was looking specifically for proof.
And when he looked at the moon, what did he see?
He saw something that just blew everyone's minds. It wasn't a smooth, perfect, heavenly sphere like tradition said it should be.
No.
No. It was a rough surface, covered in mountains and craters. He showed that the heavens were imperfect, just like Earth.
Wow. But the real smoking gun was Jupiter, right?
That was the turning point, yeah. He watched Jupiter over a period of time, and he saw these 4 bright little dots of light moving around it.
4 moons.
4 moons, orbiting another planet. This was it. This was irrefutable evidence that not everything in the universe revolved around the Earth. He had proved Copernicus was right, not just with math, but with his own eyes.
And this is where we see just how dangerous these new ideas could be.
Absolutely.
His findings went directly against the teachings of the church, the most powerful authority of the time. And Galileo got into serious trouble for it.
He was forced to recant, to say he was wrong, and he spent the rest of his life under house arrest. But, the story goes he kept studying in secret. The ideas were out. You can't just lock up curiosity.
So while Galileo is looking through his telescope, you've got Johannes Kepler, a German mathematician, doing something totally different.
He was using pure, relentless math. He had access to decades of incredibly precise data on the planet's positions, all collected by this astronomer, Tycho Brahe.
And Kepler was trying to solve this really nagging problem. Everyone, even Copernicus and Galileo, they all just assumed planets moved in perfect circles.
Because circles were seen as the perfect divine shape. It just seemed right.
But the data didn't fit.
Not quite. No matter how he ran the numbers, the paths were always slightly off.
Yeah.
His huge discovery, his breakthrough, was realizing that planets move in ovals, ellipses. It was a brutal break from tradition, but he was forced to that conclusion by the evidence itself.
So his 3 laws of planetary motion, which also said planets move faster when they're closer to the sun, they basically showed that the universe operates on specific, predictable mathematical rules.
Exactly. Even if those rules weren't perfect in the old sense, they were real.
And that takes us right to the person who tied it all together. The guy who took Copernicus's model, Galileo's physics, Kepler's math, and unified everything.
Isaac Newton.
Newton gave us the universal law of gravity. We all know the story about the apple falling.
Right, the legend. But the real genius wasn't just noticing the apple fell. It was realizing that the exact same force that pulled that apple down was what was keeping the moon in orbit around the Earth.
That's the mind-blowing part.
It was the intellectual mic drop of the century. Before Newton, you had two sets of rules, one for the heavens, one for Earth. Newton said, no, the physical laws are universal.
The physics in your backyard are the same as the physics of the stars.
Precisely. And he wrote all of this down in his book, The Principia, his 3 laws of motion. It was basically the blueprint for a mechanical universe.
So the cosmos wasn't some big mystery anymore. It was a huge, predictable machine that operated according to fixed, observable rules.
But here's the really critical question. How did they do all this? Why now? What was different? The answer is the process.
The scientific method.
They created a standardized system for finding things out. And 2 thinkers were key here.
Francis Bacon.
Francis Bacon, who championed empiricism, he said you have to build science from the ground up. Go out, gather data through careful observation, and then test your ideas with experiments.
So stop just thinking about the world and actually go out and test it.
Then you have the other side of the coin, René Descartes.
Right. He stressed logic and math.
Descartes demanded rigorous, unbiased reasoning. You need Bacon's hands-on data collection, but you also need Descartes' skeptical, logical mind to make sense of it all.
So that's the method. You start with the question, you form a hypothesis, an educated guess.
A testable guess, that's key.
Right. Then you run experiments, collect data, and see if you were right. And anyone else, anywhere in the world, should be able to repeat your experiment and get the same result.
Which made knowledge cumulative. People could build on each other's work.
Okay, so if Newton showed us the huge macro universe, another whole set of discoveries was opening up the micro universe.
The world inside our own bodies.
Yeah, and the tiny world of cells. Advances in medicine really started with a guy named Andreas Vesalius.
For centuries, doctors were just using these ancient Roman medical books, and a lot of them were based on animal dissections, which meant they were full of mistakes when you applied them to people.
So what did Vesalius do?
He challenged that authority directly. He started performing dissections on human bodies himself. He published this incredible book full of detailed, accurate drawings of muscles, bones, organs.
So he literally just replaced old errors with his own direct observations.
And then there's William Harvey. He figured out something absolutely fundamental to life.
How blood circulates.
Right. Before Harvey, the belief was that blood was sort of consumed by the organs and constantly remade. He proved that the heart is a pump.
Just a pump.
Pushing blood through the veins and arteries in one continuous closed loop. That discovery is the foundation of so much of modern medicine.
And speaking of observation, the microscope just opened up a whole new reality.
It's largely thanks to Antony van Leeuwenhoek. He was a Dutch lens maker. He built these incredibly powerful little microscopes.
And he was the first person to see a universe that was completely invisible.
Totally invisible. He looked at a drop of pond water and saw what he called animalcules, tiny little creatures swimming around.
It's hard to imagine the shock of that.
Yeah.
Realizing there's this entire busy world of life on your own fingertip.
He also saw bacteria for the first time, red blood cells. It just permanently changed how we see the world and life itself.
And another scientist, Robert Hooke, he looked at a piece of cork under a microscope.
And he saw these tiny box-like structures, and he named them cells. He had discovered the basic building block of all biology.
So we've covered the cosmos and the body. Let's talk about matter itself, the start of modern chemistry.
For that, we really have to look at Robert Boyle. He attacked the oldest scientific idea of all.
Which was?
That everything was made of just 4 elements: earth, air, fire, and water.
An idea from the ancient Greeks.
Boyle didn't just disagree. He experimented. He argued that matter was made of tiny particles that combined in different ways. And he did experiments showing how the pressure and volume of a gas are related. Boyle's law.
So he moved chemistry from just kind of philosophical speculation into a real experimental science.
Exactly. And that brings up something that connects all of these discoveries.
The tools.
Precision. The need for precise measurements. You couldn't just say something got hotter. You needed to know how much hotter.
So that's where things like the thermometer come from.
Thermometer, yeah.
Yeah.
Fahrenheit and Celsius. And Evangelista Torricelli invented the barometer to measure air pressure. Clocks got way more accurate, so you could time experiments down to the second.
It's all about making data reliable and repeatable. So a scientist in London could check the work of a scientist in Paris.
And as all this knowledge started to explode, they realized they needed a better way to share it.
So they formed scientific societies.
Like the Royal Society in England. They were places where scientists could meet, show their experiments, and debate their findings,
And they started publishing journals.
which was crucial. It created a system of peer review and open communication. It meant science could move so much faster, with people all over the world building on each other's work.
So when you put it all together, what's the big takeaway from this whole era?
Well, it just fundamentally changed how people viewed the world. It proved that through reason and observation, you could actually understand and even begin to control nature.
And this way of thinking didn't just stay in science, did it?
No, it flowed directly into the next big movement, the Enlightenment, where people started applying that same rational thought to things like government and law and human rights.
But the biggest discovery this whole time wasn't gravity or cells or the planet's orbits. It was a method itself.
That's the core idea. The most powerful discovery was the process, the idea that you personally have the ability to observe, to question, and to test the world for yourself to find out what's true.
Regardless of what any old book or authority figure tells you to believe.
Good luck with your studies.